Hi, welcome to schoolaa, your online school. In this video, we are going to cover the following topics. If they are familiar to you, please check your understanding by solving the end of video questions. Put your answer in the comment section below. If they are not, no worries, just join my class. Empirical formula is the simplest form of the molecular formula or the formula unit, or in other words, is the simplest ratio of the atoms found in a compound. Like if we have the formula of peroxide is H2O2, we can simplify it by dividing by 2 to get HO. So the empirical formula for peroxide is HO. Another example, the formula of glucose C6H12O6. We can simplify it by dividing by 2 to get C3H6O3, but this is not the simplest formula. The simplest formula should be CH2O. Sometimes the empirical formula is the same like the formula of the compound. And this happens when you cannot simplify the numbers of the atoms in a compound. Like the formula of water is H2O, the same like its empirical formula. And also the empirical formula for carbon dioxide is the same like its formula. And now let's move to our first objective, which is how to find the empirical formula of a compound knowing its percentage composition. Like here, to find the empirical formula for a compound which is 69.6 manganese and 30.4 oxygen, the best way is to draw a table like what I'm doing right now. In the first column, write the elements that you have, which is manganese and oxygen. And the second one, write their mass in 100 grams, which is the same like the percentage. In the third column, write their molar mass, which you can find it in the periodic table. And the fourth column, write the number of moles. And this one, you get it from dividing the mass by the molar mass. And the fifth column, write the mole ratio, which I'm going to explain in a while. So we list the elements that we have, manganese and oxygen, in two different rows. Then we write their mass in 100 grams, which, as I told you, it's the same like their percentage. For manganese, it's 69.6, while for oxygen, it's 30.4. Then the molar mass, we find it in the periodic table. As you can see, the molar mass for manganese to the nearest tenth is 54.9, while the molar mass of oxygen to the nearest tenth is 16. So we list them in the table that we drew, and we divide the mass by the molar mass for each element to find its number of moles. For manganese, the number of moles is 1.27. For oxygen, its number of moles is 1.9. And now please listen carefully how to find the mole ratio. To find the mole ratio, we should divide the number of moles by the lowest number of moles we calculated. Since 1.27 is the lowest, so in the first one we get the mole ratio equal to 1. In the second one, we divide 1.9 by 1.27, we get 1.5. So always we find the lowest number of moles and we divide by that number to get the mole ratio for all the elements. So the empirical formula is supposed to be MnO1.5, but since we cannot have decimals in the formula, we should multiply it by 2. Then the empirical formula is going to be Mn2O3. In general, when you have a subscript 1.5, you multiply by 2. When you have a subscript 1.3, you multiply by 3. And if you have one subscript is 1.25, then you have to multiply by 4. And as you notice, we are rounding our answers to the nearest whole number for us not to get decimals in our empirical formula. Another example about empirical formula, please solve with me and pause the video whenever is needed. We draw our 5 columns table. In the first we put elements, in the second we put their mass in 100 grams. In the third we put their molar mass, we get it from the periodic table. In the fourth we calculate their number of moles. In the fifth we find their mole ratio by dividing their number of moles by the lowest number of moles we calculated. Here we have 3 elements, so we draw 3 rows, one for carbon, one for hydrogen, and one for oxygen. The percentage of carbon is 60, while the percentage of hydrogen is 13.4, and the percentage of oxygen is 26.6. Then we find their molar mass from the periodic table. the molar mass of carbon to the nearest tenth is 12. The molar mass of hydrogen to the nearest tenth is 1. The molar mass of oxygen to the nearest tenth is 16. We list them in our table. Then we find the number of moles for each element by dividing its mass by its molar mass. The number of moles for carbon is 5, while the number of moles of hydrogen is 13.4, and the number of moles for oxygen is 1.67. As you can see, the lowest number of moles is 1.67, so I have to divide all the number of moles by 1.67 to get the mole ratio for each element. The mole ratio for carbon is 3. The mole ratio for hydrogen is 8, while the mole ratio for oxygen is 1. So the empirical formula is going to be C3H8O. In our second objective, we are going to learn how to find the molecular formula out of the empirical formula. To do this, we should multiply the empirical formula by a whole number, and that whole number can be calculated if we divide the molar mass of the molecular formula by the mass of the empirical formula. That molar mass, usually it is given in the question. Here is an example. The empirical formula is CH2 and the molar mass is 42 grams per mole. To find that whole number, we should divide the molar mass of the molecular formula by the mass of the empirical formula. Here the empirical formula is composed of 1 carbon atom and 2 hydrogen atoms. Its molar mass is 14. Then we divide 42 by 14 to get the whole number, which is 3. And then the molecular formula is going to be C3H6. We simply multiply the empirical formula by that whole number. Let's have our first exercise. Here we have to determine the empirical formula of a compound which is 43.66% phosphorus and 56.34 oxygen. And as you noticed, the molar mass is given, which is 284. As usual, to find the empirical formula, we draw our 5 columns table. In the first column we write the elements. In the second we put their mass in 100 grams. The third we put their molar mass. The fourth we put their number of moles. And the fifth we put the mole ratio. Then we draw 2 rows since we have 2 elements, phosphorus and oxygen. The mass in 100 grams for phosphorus 43.66, for oxygen is 56.34. Then we find their molar mass in the periodic table. Since we have 2 decimals here, we're going to find the molar mass for phosphorus to the nearest hundredth. It's going to be 30.97, while the molar mass for oxygen to the nearest hundredth is going to be 16. Then we find the number of moles by dividing the mass by the molar mass. The number of moles for phosphorus is 1.41, while the number of moles for oxygen is 3.52. As you can see, the lowest number of moles is 1.41, so we divide 1.41 by 1.41 to get the mole ratio for phosphorus. It's going to be 1. 3.52 divided by 1.41, approximately 2.5 for oxygen. So the empirical formula is going to be PO 2.5. We multiply by 2 to make the subscripts as a whole number. So the empirical formula is going to be P2O5. And now is the new part. To find the molecular formula, we should multiply by a whole number. That whole number can be calculated by dividing the molar mass for the molecular formula by the mass of the empirical formula. Here the molar mass of the molecular formula is given, which is 284. We should calculate the empirical mass for P2O5. We multiply phosphorus, its molar mass, by 2, and the molar mass for oxygen by 5. We add them. The answer is going to be almost 142. The answer is 2. So to find the molecular formula, we should multiply the empirical formula by 2. So the molecular formula is going to be P4O10. So as you noticed, in case you want to find the molecular formula, you should find the empirical formula first, then you multiply it by a whole number. That whole number can be calculated by dividing the molar mass by the empirical mass. Our third and last objective is how to find the percentage composition for compounds knowing their formulas. Like here, if you want to find the percentage composition for FeO or iron 2 oxide, we should find the molar mass for iron from the periodic table. It is 56 gram per mole, and the molar mass for oxygen also from the periodic table, which is 16. And then we find the molar mass for iron 2 oxide by adding 56 to 16. The answer is 72 grams per mole. Then to find the percentage by mass of iron, we simply divide the mass of iron by the total mass multiplied by 100. So 56 divided by 72 multiplied by 100. The answer is going to be 77.8%. And the percentage by mass of oxygen is going to be the mass of oxygen over the molar mass multiplied by 100. So it's going to be 16 divided by 72 times 100. The answer is going to be 22.2%. So the percentage composition for FeO is 77.8% iron and 22.2% oxygen. And now let's try to find the percentage composition for Fe2O3, or what do we call it, the Fe3 oxide. Here, to find the molar mass for iron, we should multiply by 2, since we have 2 moles of iron in every mole of iron 3 oxide. So the mass of iron is going to be 2 times 56, and the answer is going to be 112 gram per mole. And here also we have 3 moles of oxygen and 1 mole of iron 3 oxide. So to find the mass of oxygen, we should multiply by 3. So 3 times 16, the answer is going to be 48 grams per mole. The total mass for iron 2O3 is going to be 160 grams per mole. And to find the percentage by mass for iron, we are going to divide the mass of iron, which is 112, by the total mass of Fe2O3, which is 160, multiplied by 100. And the answer is 70%. The percentage by mass of oxygen is going to be equal to 48 divided by 160 multiplied by 100, which is equal to 30%. So the percentage composition for Fe2O3 is 70% by mass iron and 30% by mass oxygen. As you notice, the percentage of oxygen in the second compound is more. That's why its color is darker. Usually the color of FeO is more reddish, while the color of Fe2O3 it's darker. And now you are ready to solve the end of video questions. Please, if you are not, repeat the video again. Otherwise, solve the questions. Put your answer in the comment section. If you have any question that I didn't cover in the video, please share it with me in the comment section. Share this video with your friends. Subscribe to my channel to stay tuned for more videos. See you in other videos, and good luck.